We're going to take a look at a monomial times a polynomial, which is just kind of a fancy way of basically saying distribution. Okay, so when we're multiplying a monomial times a polynomial, we're really just distributing, which means we're going to be doing just a couple of multiplication problems along the way. So one thing that we need to remember is how to multiply variables with exponents. Okay, so when we're multiplying, the general rule is that we add, oops, that's a little bit big, isn't it? We are going to add the exponents, okay? Because exponents are really just talking about repeated multiplication. So if we have x times x to the second power, that's really saying x times, and x to the second power is really just x times x. So we're multiplying x 3 times there, x times x times x. So we would get an x to the third. So you can remember that there's that sneaky little exponent of 1 there, even though we don't write it, and 1 plus 2 is 3. So when we are multiplying and we have coefficients, the coefficients, or the numbers out in front, they just get multiplied to each other, right? Normal numbers work normally. So out in front of this x squared, there's really a 1. 1 times 3 is just 3. X squared times x to the third is going to be x to the 2 plus 3 is 5. And then again, when we multiply, we just multiply the coefficients like we would any other normal multiplication number. 4 times 6 is 24. X to the third times x to the fourth is x to the 3 plus 4 is 7. Okay? So we just need to remember that in order to multiply these polynomials correctly. Okay. Or multiply the monomial by a polynomial. So when we're distributing, we want to take this number on the outside. So it's 3 times the quantity, 2x squared plus 3x plus 4. So when we do this, everybody inside the parentheses needs to be multiplied by that 3. Okay, so 3 times 2x squared. There's no variable part in the monomial that we're distributing, so we don't really have to worry about doing that multiplication. It's just going to be x squared, but we do need to worry about 3 times 2, which is 6. And the x squared stays the same because it was the only variable part in that multiplication. Next distribution, 3 times 3x, that'll be 9x, and that's positive, so I'm writing plus. And then 3 times 4 is 12, and again, that's positive, so I'm going to write plus 12. And we're done. So we're just going to keep doing this here. So this time we're distributing an x. If it helps, you can put that little 1 coefficient out front to remember that when we're multiplying, the coefficients are just multiplying. So 1 times whatever normal number is in there, not the variables. So 1 times 2 is just 2. And x times x is x to the second power, right? We're multiplying x times x twice there. And then 1 times 7 is just a positive 7, so we're going to say plus 7. Oops, and then, sorry, the x as well. So we are distributing that x over there, but there's no x, so this x just gets distributed over. There you go. Let's take a look at a couple more distribution problems, then we're going to take a look at how to find a missing value. So this time when we distribute, just make sure you're distributing to every term inside the parentheses, right? Multiply your coefficients to your coefficients, your variables to your variables. So 2 times 5 is 10. X times x squared is x to the third. 2 times, and just watch out for your signs. That's going to be a negative 3 is negative 6. We're going to write down minus 6. And x times x is x squared. 2 times a negative 8 is a negative 16. So we'll write negative 16. And then we're still distributing that x over there. And it becomes a variable part there for that last term. All right, last one, distributing. So this is a little bit different because now we have an exponent other than 1 on that monomial that we're distributing through. But it's going to work the same way. 3 times 4 is 12. Y squared times y to the third is y to the fifth. 3 times a negative 5 is negative 15, so we write minus 15. Y squared times y squared is y to the fifth. 3 times 2 is 6, so plus 6. And then we're distributing that y squared over as well, but it doesn't change what it looks like because there wasn't another variable part that it was being multiplied by. Okay, so the next thing we're going to do is look at what happens if we're given a problem, but we have some missing values inside of that problem that we're asked to find. So this is still a distribution problem, but we're given more information in some places and less in others. So what we're going to do is we're just going to go ahead and do our distribution, and then we're going to take a look at the answer a little bit later. So I'm just going to do my distribution here, and I'm going to pretend that there's a number in for this k right here, and we'll kind of figure it out down along the road. So if I keep distributing, so 2x times 2x squared is going to be 4x to the third. Then if I multiplied 2x times kx, well, normally I would be multiplying 2 times k for my coefficient, and then x times x would become an x squared. Okay, and then 2x times negative 3 would be minus 6x. Now I'm saying that this needs to equal, and this time I'm going to write it underneath. This needs to equal this guy over on the right. So I'm going to write my like terms under my like terms. So I should have 4x cubed plus 10x to the m minus 6x. That's what that needs to equal. Okay, so 4x cubed and 4x cubed are good. They match up just fine. Negative 6x and negative 6x there, good. They match up just fine. So what we need to look at is this 2 times k and this x squared and this x to the m and the 10. Okay, so what I'm going to do first is I'm going to match up these coefficient parts and say, okay, well, these need to be equal to each other. 2k needs to equal 10. 2 times k needs to equal 10. So we need to ask ourselves, what does k need to be in order to make that true? So I can solve this little equation by dividing both sides by 2 and finding that k needs to equal 5. The next thing is we're going to look at these x's here. I'm going to say, oh, well, x squared needs to equal x to the m. So what does m need to be to make that true? Well, m needs to equal 2. Okay, we can check that this is correct. So let's see, how can we check this? Oop, let's not zoom quite so much. Okay, how can we check this? So what we can do is go back to our original problem on the left-hand side, substitute in those numbers, distribute, and check and see that we get the right answer. So let's write this. If we have 2x times 2x squared plus, we said k needs to be 5x minus 3. Okay, so let's see what happens. So we get 2x times 2x squared, which is 4x cubed. 2x times 5x is 10x squared. And 2x times negative 3 is negative or minus 6x here. So that's what we get, which then if we put 2 in for our answer there, that works and they should match up. All right, let's do another one. So we're going to start by simply doing our distribution. And if we have any coefficients that are unknown, we're just going to write them as multiplication. So we're going to go ahead and distribute. So we're going to have bx times 2x squared. So normally we would take b times 2, and then x times x squared is x cubed. Next distribution would be bx times a negative 5x. So I'm going to write this a little bit differently to try to help us sort things out a little bit. I'm actually going to write this as addition, say plus b times -5. So I'm going to keep that negative with the 5. And because I kept it there, I'm going to write this as addition. And then x times x is x squared. And then we're going to do the last distribution here. Bx times 4 is going to be b times 4x. Okay, now let's write underneath what we should have gotten for our answer and try to match up these different pieces. So our answer should have been -8x to the c plus 20x squared minus 16. Ooh, there is a typo in this problem. There should be an x here. Okay, so let's just fix that real quick, because otherwise this doesn't work very well. Okay, so there's a couple different ways to go about this. And I'm going to choose just to work with the first term because it doesn't really matter where we find our b. It just matters that we find it once. Once we find one b, we know all the other b's are going to be the same. So I'm just going to work with my first term here. So here I can pull out these coefficients. I'm going to say, all right, well, b times 2 needs to equal -8. And we can solve that by dividing by 2, find that b needs to equal -4. The next unknown we had was this c. All right, well, that's right up here. So we know that x cubed needs to equal x to the c. And for those things to be equal, that means that c has to be 3, because that's the only thing that's kind of different about them. They both have a base of x, which means to be equal, they both need to have an exponent of 3.